What's up everybody, this is Teacher Ivan from NextGen Academy. Our goal in this channel is to help you achieve your highest potential and to help you understand subjects in the easiest and the most efficient way. If you'd like to get more tips and tricks on how to achieve A star in your IGCSE, don't forget to like, comment, share and subscribe to this channel. Lastly, if you need any help in your studies, you can always head on to our website, link in the below, or our Instagram, drop us a DM and we'll be able to help you. Enjoy this video and I wish you all the best.
All right. Okay, welcome back, my NextGen family. Okay, this is the final non-calculator paper for May-June 2025, paper 1-3. Okay, so this is a non-calculator paper. We are not going to use our calculator, put it aside. 80 marks, 2 hours. Okay, so please, if you haven't done all the other papers, do your other paper all without calculator, time yourself also, and then that's how you'll improve. Okay, we'll go straight to the questions here. Okay, let's look at question 1A. The diagram shows the graph y equals to 2x plus a, x plus b, x plus c, where a, b, and c are integers. Find a, b, and c. Okay, how do you find a, b, and c? Okay, how do you find a, b, and c? Okay, number one, we have to look at the roots of the equation, right? So we got here, these three roots, -2, this, and this. Okay, what's this? This one is 1/2. So we've got three values here. Then we are going to construct the equation. Okay, so how do we put into this form? All this is the roots. We can write it like that. X is equals to -2, right? X equals to -2. Then, okay, maybe we start with the half first. X is equals to half. Then x equals to -2. X is equals to 1. Okay, we write down the roots. Then we rearrange it to equals to 0. Okay, but for fraction, we write like that first. 2x equals to 1. 2x plus 1 equals to 0. Okay, this one will be x minus 2 equals to 0. And this one is x minus 1 equals to 0. So how do we write it? Y equals to 2x plus 1, x minus 2, x minus 1. Wait. X plus 2. Okay, sorry, my brain a bit rusty today. Okay, write it into this form. Okay, you can just leave it like this, or if you want to write it as A, B, and C, also up to you. Okay, so A is equals to 1. Okay, B and C doesn't matter which is which. Okay, B and C you can interchange with each other. So B, according to mine, is -2. C, why I keep writing -2? X plus 2. Okay, B equals to 2, then C is equals to -1. Okay, the next one, use the graph to find the values of x for which y is more than or equals to 2. Okay, so y more than or equals to 2, we need to draw a line y equals to 2 on the graph over here. Okay, so here is y equals to 2. Okay, then from here, where exactly is more than this point? So this section here, okay, in between these 2 points, and then this part here. All right, we got to read carefully these points here. We've got -1, then here is -1.7, and here is 1.2. Okay, so we need to express these three parts here. So you got x in between -1.7 to -1, then x is more than or equals to 1.2. Okay, you need to express all of these 3 points to get the 3 marks. Okay, if number 1 can do, can you type 1? Okay, easier. Don't be like teacher just now, do so many careless mistakes. Okay, so in exam need to double check, triple check it. Okay, number 2. Find the values of k for which the equation x squared plus 4kx plus k plus 3 equals to 0 has 2 equal roots. So what does it mean has 2 equal roots for a quadratic equation? We'll use b squared minus 4ac equals to 0. Okay, so this is a, b, and c. Okay, a, b, and c. b is equals to 4k squared minus 4 times 1 times k plus 3 equals to 0. All we need to do is we solve this equation. 16k squared minus 4k minus 12 equals to 0. Okay, this time we're going to divide the whole thing by 4. 4k squared minus k minus 3 equals to 0. Then we factorize this. 4k 4k plus 3 k minus 1. Then we'll get k equals to negative 3 over 4. K is equals to 1. Okay, so just a gentle reminder, how many type of roots do we have? We have equal roots. Okay, this one is 2 equal roots. We have 2 different real roots or 2 real roots. We have no real roots. Then one more is has real roots. Okay, remember got 4, not just 3. All of this, you need to remember, equals 0, more than 0, less than 0. If has real roots means it is inclusive of the first 2 statements. So more than or equals to 0. Remember all of this. This is from your chapter 2. Okay, if you can do this, number 2, just type 2. All right, let's go to number 3. The polynomial p is such that px equals to x cubed plus ax plus 30, where a is a constant. Px is divided by x plus 2, the remainder is 84. Write p as a product of linear factor. This is a 5-mark question. Okay, so factor and polynomial most likely will come out in paper 1. Okay, you can do this without calculator. So let's start with what they gave us here. They say it is divided by 2, remainder 84. So we're going to use remainder theorem. X plus 2 equals to 0. The x value that we're going to substitute in is negative 2. So p negative 2 is equals to 84. Right? So here will be negative 2 cubed plus negative 2x plus 30 equals to 84. All right, so negative 2 cubed, this will be negative 2 times negative 2 times negative 2, negative 8 minus 2x. Okay, 30, we can bring it to the right-hand side first. This one will be 54. This is negative 2a. Okay, negative 2a equals to 54 plus 8. 54 plus 8 will be 62. Then we divide by negative 2. Okay, so a is equals to negative 31. All right, from here, we will have px equals to x cubed minus 31x plus 30. What do we do from here? Okay, from this point, we have to find out what is the factor, because they didn't give us the factor, right? Okay, so how do we determine what are the factors or what is a possible factor? We need one factor, okay, at least one factor. So you're going to look at the value of the last value, the d value. Okay, so to find the factor, use value of d. Okay, our d value here is 30. So what are the factors of 30? You just list it down, but I don't think it will be very hard for you to find. Again, they won't make it until like a fraction. They will normally give you a whole number. So factors of 30, we can say is 1, 2, 3, 5, 6, 10, 15. Right? Okay, so it will be one of these, and all of it, you put a plus minus to it. So it's either a plus 1 or minus 1, plus 2 or minus 2, plus 3 or minus 3, plus 5 or minus 5. Okay, either one of it. How to know? Okay, so what we are going to do is we use factor theorem to test first. You all don't go and straight away go and divide it. Okay, so use factor theorem, which is when you put in the x value, then it becomes 0. So let's say we put 1, P1, okay? This is our test, where my x is equals to 1, 1 cubed minus 31 times 1 plus 30, okay? Like this one, actually, they give you quite obvious already, right? Okay, you see 1 minus 31 plus 30, this is equals to 0. So when x equals to 1, so x minus 1 will be a factor. Because now the x equals to 1 satisfy this equation. So we can say that as we divide by x minus 1, we will get the other quadratic factor. Okay? So you use factor theorem to test first. Don't straight away jump the long division. Otherwise, later on, if you keep testing, then you cannot get the value. Okay, from here, now we do long division. Okay, long division. Okay, long division, you see also there's one value that's missing. So we are going to put the x squared as 0. Minus 31x plus 30 divided by x minus 1. Okay, here, x squared, x cubed minus 1x squared. Okay, you can put a negative here. Okay, if you put the negative, you can put like that also. Okay, so negative, negative, this one will be positive 1x squared. So x squared minus 31x plus, what's this next one? X squared minus x. Put a minus here. Minus 31 plus x, we get minus 30x plus 30. Okay, we get minus 30. So minus 30x plus 30. Okay, so now our px can be written as x minus 1, x squared plus x minus 30. Okay, the final one, we are going to factorize the quadratic factor. So here will be x minus 1, x plus 6, and then here, x minus 5. Okay, factor and polynomial, very high chance it is a paper 1 question. If you see all the older paper also, they always say do not use a calculator. Okay, you can do this, type 3. Okay, let's go to number 4. Okay, number 4, this one I think it's a pretty easy one. Log. Okay, so solving of log. This one all don't need calculator, right? Okay, solving of log, this one, 2 log x10 log x plus 4 equals to 2. Okay, first thing, we have to change all of them to be the same base. Okay, what can we do here? Is either we change both to log x or log base 10. Okay, LG. What I will do here is I will change the log x10 to log 10. Okay, how to change log x10? Log x10. I write down like that first. Log 10 over log x. Log 10 is 1 over log x. Okay, so this will be 2 over 1 over log x minus log x plus 4 equals to log 2. 2 divided by a fraction, okay, you will get 2 times log x over 1. So we'll get 2 log x minus log x plus 4 equals to log 2. This one you get log x squared, log x plus 4 equals to log 2. Log x squared over x plus 4 equals to log 2. When you both sides got log, here will be x squared over x plus 4 equals to 2. And then we multiply, x squared equals to 2 bracket x plus 4, 2x plus 8. Shift everything to one side. And then we factorize it. X minus 4, x plus 2 equals to 0. X is equal to 4. X is equals to negative 2. Okay, are both of these answers acceptable? All right, okay, because you look back to the question, they say the domain of x is more than 0. So we need to write here reject. Okay, number 4, if you can do, this type 4. All right, okay, let's go to number 5. Okay, number 5, so far, I can pretty much, pretty much bet that the next one, the next paper, most likely lah, okay, circles will come out in paper 1. Okay, so I don't think will be very hard for us to do this one. Okay, so you also try your best. They say even though what solution by accurate drawing will not be accepted, right? You just try your best to sketch it out for you all to understand it clearly. Okay, let's look at this here. A circle C has equation x minus 5 square plus y minus 12 square equals to 100. Find the equation of the tangent to C at the point 11, 4. Give it in ax plus by equals to C. Okay, first of all, we need to understand circle equation first, which is x minus a square plus y minus b square equals to r squared. Center is AB. Okay, so center is AB. Then here is r squared. So what can we conclude from here? The center is 5, 12. R is equals to square root 100. Okay, or you can just write r equals to 10. Okay, we sketch it out first. They want us to find equation of tangent. Okay, how does this equation of tangent look like? Okay, maybe it's like this. Okay, we got a circle. We've got a center, 5, 12. Then we have 11, 4. Okay, 11, 4 maybe it's around here. Then we have a tangent. Okay, so here, 90 degrees. Okay, what is the relationship? So we find what is the gradient of the center to the point first. Okay, gradient center to point. Okay, let's call this M. Okay, M is equals to y2 minus y1. So 12 minus 4 over 5 minus 11. Okay, then here we will get 8 over negative 6, which will get negative 4 over 3. Then from here, okay, from here, we want to find what is the gradient of the tangent. Gradient of tangent, we just do the negative reciprocal. So it's 3 over 4. Okay, then now how do we find equation of tangent? We will substitute into y minus y1 equals to mx minus x1. The point is 4, 3 over 4, x minus 11. Here will be 3 over 4x minus 33 over 4. Okay, they want it in a certain form, right? Okay, they want it in ax plus by equals to c. Okay, so for me, don't need to go and change it to y equals mx plus c. We want to get rid of the 4 at the bottom. First, we multiply the whole thing by 4. So this will become 4y minus 16 equals to 3x minus 33. Okay, I will shift everything to the right-hand side. So 3x minus 4y minus 33 plus 16 equals to 0. So 3x minus 4y minus 33 plus 16. Sorry, they want it in equals to c, my bad. Okay, so here we will take minus 16 plus 33. Okay, so we get 3x minus 4y minus 16 plus 33, we will get positive 17. Okay, now show that C and the circle with equation x squared plus y squared equals to 4 do not intersect. Okay, we have this circle. Okay, we have this circle. They are asking us to find another circle. Okay, what is this circle? The center is 0, 0, and the radius is 2. Okay, center is 0, 0, and radius is 2. Okay, I try to sketch it out. Center, design center, 0, 0, r equals to 2. Okay, they say we want to show that it does not intersect. Okay, how do we show this one? This is actually one of the examples in your textbook also. Okay, so we got here Sorry, 0, 0 should be at the bottom lah. The other way around. Like this. 0, 0. Okay, how do we prove that they do not intersect with each other? You all remember this part? Okay, so what do we do? Number one is we find out what is the distance between the centers by using length of radius first. Distance between the centers, sorry, not length of radius, by using the center, okay, the length between the centers. Okay, then we also know that here is equals to 2, then just now the radius above is equals to 10. Okay, so first thing, what we're going to do here is you find this length first. Okay, distance between centers. We're going to use length formula. Square root 5 minus 0 square plus 12 minus 0 square. 5 square plus 12 square, 25 plus 144. This one we will get 169, which is equals to 13. Okay, so between here and here, the length is 13. Now, the distance between the radius is equals to 10 plus 2, 12 only. Okay, now how do we prove? Because 13 is more than 12. The distance is bigger than the sum of the distance between the radius. Right? You just need to write like that. Therefore, no intersection. Okay, number 5. If you can understand this, can you type 5? And so far all the circle question. Okay, so again, if you haven't because we don't have a lot of questions right now, just go through the textbook example, go and redo all the textbook example. Okay, so far all the questions is from there already. I don't think there's anything else. Don't need to go and do the A levels kind of circle examples and all. I don't think it will come up. Okay, because some of you or maybe some of your teachers say give you all the A levels type of circle question. I don't think it will come out until so advanced. Okay. All right, let's go to question number 6. Okay, number 6 is another log question. Find the x coordinates of the point of intersection of the following curves. Give your answer in exact form. Okay, you got equation 1, you got equation 2. Let's sub in both the equations to each other. Okay, they say give your answer in exact form. That means we want to solve for the x. Okay, solve for the x. So it's just sub both of it with each other. 4 ln x equals to 5 minus 3 over ln bracket x squared. Okay, first thing we do the ln x squared to become 2 ln x. Okay, from here, we are going to multiply the whole equation by ln x. Okay, maybe if you don't want to change here yet, you can do the let method first. Okay, let m, okay, or any alphabet equals to ln x. We get 4m equals to 5 minus 3 over m. Multiply this by m. So it becomes a quadratic equation. 5m minus 3. We get 4m squared minus 5m minus 3. 8. Got one more 2 here. Oops. Okay, looks like here I do something wrong. Okay, here times 2m. Okay, gotta redo this part. Times 2m. So 8 8m squared equals to 10m minus 3. So 8m squared minus 10m plus 3 equals to 0. Yeah, okay, no worries, guys. Later I'll go through that one. Okay, now let's factorize this. We will get 4m minus 3, 2m minus 1 equals to 0. M, 3 over 4, m, 1 over 2. We're going to convert it back to ln x. Ln x equals to 3 over 4. Ln x equals to 1 over 2. Okay, since they want in exact value, we just change the ln. We inverse ln to become e. So x is equals to e to the power of 3 over 4. X is e to the power of 1 over 2. This is question number 6. Okay, please type 6 if you can do this. Okay, if you write it as 0.75 and 0.5 also can. Okay, don't have to be in fraction. Let's go to question number 7. Question number 7. In this question, all lengths are in centimeters and all angles are in radians. The diagram shows a sector of a circle with center O and radius x. It is given that the area of the triangle is 9 cm squared. Find the value of sine theta. Okay, the area of triangle means the formula 1 over 2 AB sine C. We substitute 9 equals to 1 over 2, 6 times 6 sine theta. Okay, let's solve for this. This one will be 18 sine theta. Sine theta is 9 over 18, which is 1 over 2. Okay, so let's write here 1 over 2. Okay, next one. It is also given that the exact area of the shaded segment is 15 pi minus 9. Find the exact length of arc AB. So why did they give us the shaded segment? What is it? What are we trying to find here? Okay, we got sine theta equals to 1 over 2. Okay, let's see what do they want to give us here. So how to find segment? Okay, how do we find segment? Segment is we take the sector minus the triangle. Okay, so we can write like this. Area of sector minus area of triangle equals to area of segment. Okay, you know which is which? Sector is this part. Triangle is this part. Segment is this part. Okay, the top part. So sector, half r square theta minus 9. Okay, what's the r square? 6 square. Okay, maybe I straight away write 6 square. Half 6 square theta minus 9 equals the 15 pi minus 9. Okay, both sides got minus 9, so we don't want. So here will be 36 over 2 theta equals to 15 pi. Okay, from here, we can simplify. This is 18 theta equals to 15 pi. Theta is 15 over 18 pi. Then the final one. Okay, see, I also write wrong again. Here is not 1 over 2. So now the here that we calculate is 15 over 18 pi. So now the final one, we want to find the length of arc. Okay, arc S equals to r theta. So 6 times, we can simplify this, right? Okay, we divide by how much? Divide by 3. This will be 5 over 6 pi. 5 over 6 pi. This will be 5 pi. It should be 5 over 6 pi. 4-mark question. Can simplify. Teacher didn't see. Okay, question number 7. You're good. Can you type 7? Okay, let's go to question number 8. The diagram shows part of the curve y equals 3 over x plus 1 minus x minus 2 over x. The points A and B lie on the curve such that the x-coordinate of A is 1 and the x-coordinate of B is 2. Find the y-coordinates of A and B. We are going to substitute A equals to 1. Okay, so substitute x equals to 1. Then for B is x equals to 2. So y equals to 3 over 1 plus 1 minus 1 minus 2 over 1. 3 over 2 minus 2 over 1. So minus 2. 3 over 2 minus 1. 3 over 2 plus 1 is equals to 5 over 2. Okay, for B, x is equals to 2. Y equals to 3 over 2 plus 1 minus 2 minus 2 over 2. 3 over 3 minus 0. This one is equals to 1. Okay, so for A, point A here, we can just label here, which is 1 and 5 over 2. For B is 2, 1. Okay, next one. Show that the area of the shaded region enclosed by the line AB and the curve A over 4 is A over 4 minus ln B over 2. Okay, where we have to find A and B. So let's plan from the graph here. Okay, to find the area of the shaded region, we need to take the area of the trapezium minus the area of below this curve from 1 to 2. Okay, let's see. We integrate first. Okay, let's do the integration. 1 to 2, 3 over x plus 1. Okay, 3 over x, let me see, minus x minus 2 over x dx. Okay, for this part here, the x minus 2 over x, we have to separate it. Okay, we get to separate the entire thing. So integrate 1 to 2, 3 over x plus 1. Okay, be careful on this one. It's the minus the whole thing. So minus x over x, then minus 2 over x dx. Which will get 3 over x plus 1 minus 1 plus 2 over x dx. Okay, now we integrate. We check at the bottom first, both of them are x to the power of 1. So here we gotta write it as 3 ln modulus x plus 1 minus x plus 2 ln x dx. Okay, is it necessary to write the modulus? Actually, it depends. Okay, it only matters if your answer inside, if you get a negative value. Okay, when you sub in the value, but this one won't get a negative because it's plus. So we substitute. Oops, sorry, presentation all wrong. 1, 2. Okay, we're gonna substitute it in. So I just substitute straight away. 3 ln 2 plus 1, 3 minus 3, 2 ln 2 minus 3 ln 1 minus 1 plus 2 ln 1. Okay, let's write here 3 ln 3. Wait, this is 2 minus 2. Okay, we'll get here minus 2 plus 2 ln 2 minus 3 ln 1 plus 1. And this one plus 0. Okay, how can we simplify this? Okay, they want the ln later to all put into 1. So I will gather all the ln together. This, and this. Let us put it into, let's change it all to power first. Ln 3 cubed plus ln 2 square minus ln 1 cubed. Then minus 2 plus 1. Okay, here will become ln 3 cube times 2 square over, is this 1 or 2? Okay, 3 ln 1. Okay, this one should be 3 ln 2, not ln 1. Ln 2, ln 2. Okay, over 2 cube. Minus 2 plus 1, minus 1. Okay, how to simplify this one? 2 square, this one cancel. This one become 1. 3 cube is 27 over 2. So we'll simplify to ln 27 over 2 minus 1. Okay, the simplifying part sound a bit lengthy. So now we go and find the area of the trapezium. Okay, let's find area of trapezium. The formula we're going to use is half a plus b times height. So 1 over 2, 5 over 2 plus 1 times 1. And we get, here is 1 over 2, 7 over 2, 7 over 4. Okay, final one. Area of the shaded region. Okay, we're going to take the area of the trapezium minus ln 27 over 2 minus 1. Okay, how do they want it? They want it in a over 4 minus ln b over 2. So 7 over 4 plus 1, we will get 11 over 4 minus ln 27 over 2. All right. Okay, question number 8. If you can do this, can you type 8? Okay, no question, huh? Okay, we take a short break first. Okay, when we come back, we'll discuss 9 to 12. Okay, I want all of you, please try your best to understand the, especially the kinematics side. If you all haven't tried the paper, okay, please go and try the paper first. Okay, let's do question 9. Fx is negative 2x squared plus 9x minus 10, where x is from 0 to 3. Okay, they want us to write into this form. What form is this? This is called your CTS form. To do CTS, okay, let's do this. We first factorize the a value. Okay, I am going to factorize it from a and b first. Okay, you want to factorize from a, b, and c also can. Then we will do this. X minus x plus b over 2 square minus b over 2 square. Okay, so remember this one. If a not equals to 1, okay, then factorize a from ax square and bx first. Okay, this is the method that I do. Then second step is your x square plus bx will become x plus b over 2 square minus b over 2 square. The reason why I ignore the c first, because the c is not part of the completing the square process. So we've just focused on this part here. Oops. Okay, just this part. All right, now let's simplify the inside the bracket. 9 over 4 square minus 81 over 16 minus 10. Then now open up the bracket. X minus 9 over 4 square minus 81 over 8 minus 10. Sorry, this one is plus 81 over 8 minus minus. Simplify. Okay, this one will be 81 over 8 minus 10. This will be plus 1 over 8. Okay, they want it in that form. So let's write it as 1 over 8 minus 2x minus 9 over 4 square. Okay, the next one. Determine whether or not F inverse exists. Okay, this often comes out in a quadratic question, right? But this one, they structure it a little bit different from last time. Last time, they always say, find the x value where the F inverse exists. Okay, for this one, does it exist or not? Okay, and how do we know whether your F inverse exists? So this is going back to your very, very first part in your entire textbook, where we talk about the relationship. What type of relationship the F inverse exists it is only a one-to-one function. Okay, so F inverse exists for one-to-one function only. So this is what we need to check. Okay, so what do we do over here? You check for this graph. This is a quadratic graph. We need to check where is the turning point. So according to what we found from the CTS here, this and this value, your turning point is 9/4 and 1/8. Okay, 9/4, 1/8. Now, normally for it to be a F inverse exists, you will take here to the right or here to the left. Either one of it. So the domain that they gave us right now is from 0 to 3. X is from 0 to 3. In relative to here, where is 0 and where is 3? Okay, 9/4 is how much? How much 9/4? 9/4 is 2.25. Right? 2.25. So 0 and 3 is probably somewhere here and here. This is our x equals to 0 and x equals to 3. So if we take the domain from here to here, this will still be a many-to-one function. So how do we write our answer? Okay, this is just a 2-mark question. So you can write here, turning point. Okay, so the above one, I'm just drawing out to explain the full understanding. Turning point is 9/4, 1/8. Okay, then we can say that F inverse does not exist as the given domain. Okay, what's the given domain? 0 to 3 includes the turning point. Okay, or something along these lines. You can also say that it will still be a many-to-one function for the fx. Then when you inverse it, it'll be a one-to-many. So one-to-many is not a function. Okay, this one is question 9a. Okay, let's go to question 9b. Okay, recently I've been seeing a lot of this exponential and ln type of question, but you must take note on how to figure out, like let's say if it's a negative 2x here, how do we sketch it? All right, so if you're not clear, this one, go to the last section of exponential and ln chapter in Thinkific. Go and watch it. Okay, the function g is defined by gx ln 5 minus 2x from 0 to 2.5. On the axis, sketch y equals to gx. Okay, state the exact value of the intercept with the coordinate axis and the equation of any asymptote. Okay, first, what is the shape of this? We need to determine this. S. Okay, what's the shape? So we will sketch the original one first. Okay, this is how I'll do. You start with ln x first. What is ln x? Ln x is like this. Then you need to figure out what is minus 2x. Okay, minus 2x means all your x value is multiplied by minus 2. Negative 2 means what? How does it look like right now? Your graph will now all multiply the x value multiplied by a negative. That means it will go over here already. Got it? Everyone understand? This is your ln, right here, ln negative 2x. Okay, I don't know how far is it yet. I haven't do all the calculation. Okay, then because of 5 minus 2x, 5 minus 2x means you move to the right by 5. Okay, from here you also can find what's your asymptote already. Okay, so we jump is SIA. What's the asymptote? Okay, calculation for asymptote is you take the 5 minus 2x equals to 0. Okay, you take the argument equals to 0. So minus 2x equals to 5. X is equals to minus 5/2. Okay, minus 2.5. So minus, wait. Is it minus 2.5? No. Positive 2.5. It is minus 5. Okay, positive 2.5. So now how will it look like, the graph? Okay, it will look something like this. Because the asymptote is here. Okay, x equals to 2.5. So your graph all shift to the right by 5 units. This one will be ln 5 minus 2x. So you need to know the general shape of the graph like this first before you even go and do or you go and sketch it. Most of the time, I think students will get a bit stuck from the shape already. Okay, then from here, the next thing, after we have found the shape, let's find what is the intercept. We need to calculate what is the x and y intercept. Okay, what's the intercept? We are going to find x-intercept, y-intercept. So x-intercept, y is equals to 0. So 0, okay, what's the calculation here? 3 ln 0 equals to 3 ln 5 minus 2x. 0 equals to ln 5 minus 2x. E to the power 0, 5 minus 2x. 1 equals to 5 minus 2x. 2x is equals to 4. X is equals to 2. Then we've got our y-intercept. X is equals to 0. Okay, then here, y is equals to 3 ln 5. Okay, so we got these 2 points here. X equals to 2 and y equals to 3 ln 5. Okay, let's sketch back into the graph here. This one 3 ln 5 and x equals to 2. Okay, what else do they want us to do? You look at the domain here. They only want from 0, okay, that means from here, up to less than 2.5. 2.5 is the asymptote. Okay, that means we are only going to sketch this part here. Okay, according to this graph, only this small section here. So let's draw the asymptote first. Okay, let's say here is 2.5. X equals to 2.5. Okay, then we're gonna label here 3 ln 5 and 2. Okay, the shape goes like that. Okay, so it will go very close to the asymptote. Don't go and bend it back. So you go very, very close, then it's like almost straight already. This is a 3-mark question. Okay, last one. Sorry, second last one. Find an expression for G inverse X. Okay, so Gx equals to 3 ln 5 minus 2x. Okay, I will do this one. Let y equals to G inverse X. Gy equals to X. 3 ln 5 minus 2y equals to X. Ln 5 minus 2y equals to X over 3. Okay, then from here, we're going to do 5 minus 2y equals to e to the power of x over 3 minus 2y equals to minus 5. Okay, wait, I want to rearrange here. 5 minus e to the power of x over 3 equals to 2y. 5 minus e x over 3 over 2 equals to y. Okay, the last one, just rewrite it, G inverse x. 5 minus e power x over 3 over 2. Okay, the last one, find the domain and range of G inverse. Okay, so for G inverse, the domain and the range, we relate it back to the Gx. Okay, so the domain for Gx, G inverse x, domain will become the range. Then the range will become the domain. Okay, let's see from the question, what is the domain of Gx? domain of gx is 0, x to 2.5. Okay, so we will rewrite it into the range is g inverse 0, 2.5. Okay, this one is your answer for the range. Okay, the range of gx, this one we have to look at the graph. Range, your y value is everything less than or equals 3 ln 5. Okay, so we can say that the range here, if for g is less than or equals 3 ln 5. So now the domain of g inverse x, we will just present it as x less than or equals 3 ln 5. Okay, in exam, you only write these two, range and domain. All right, question 9. If you can do 9, then you type 9. All right, okay, we're going to do question 10 right now. This is a vector question. The diagram shows 4 points, O, A, B, C. A, B, and C lie in the straight lines and are such that AB to AC, AB over AC equals to 1 over 3. OA is A, OB is equal to B. Find OC in terms of A and B. Simplify your answer. Okay, so let's look at what information is given to us. This is a 3-mark question. We can use with what they give us here, OC, because you see we can find AC here. Can we use OA plus AC? Okay, so I'm gonna find what is AC over here first. AB over AC equals to 1 over 3. Cross multiply, 3AB equals to AC. Okay, AC, can I say is the AB, we can write it as OB minus OA, right? This is according to the position vector, which is 3B minus A. Okay, so we can write as minus 3B plus 3B, okay, or 3B minus 3A. Okay, so from here, we use OC equals to OA plus AC. OA is A, AC is, oops, here should be minus 3A. A minus 3A plus 3B, which will get minus 2A plus 3B. Right, so this is the first one. Okay, the second one, okay, what I'm going to do, I'm going to just copy this diagram down first, okay, so that we can see how to do this specific question. Okay, I'm going to paste it here. Okay, so we can all see how to do this question. All right, this is a 5-mark question. The line OA is extended to the point D such that OA to AD is equals to 2 to 7. Okay, so OA to AD, we should know this one, OA to AD. So this one is probably like 7 times. Okay, but we will just roughly estimate. It's probably around here. Okay, I don't know where exactly is it, but let's just assume D is probably around here. Okay, but what I know is that this is 2 parts, this is 7 parts, and they are related to this ratio here first. Then we have another one. Point E lies on CD. Okay, let's label this one is D. So we got CD. So if I were to draw it out, let's say here, this CD, point E lies on CD such that OE, O to E is lambda B. So can I say that E probably is somewhere around here? Okay, this one just a rough estimate. Find the value of lambda. All right, what I'll do here, okay, let's find out with whatever information that we have. Let's try to simplify it first. Okay, OA to AD. You give us here, OA to AD is equals to 2 to 7. Okay, so can I write as OA over AD equals to 2 over 7? This is A over AD, which is 2 over 7. And can we write here, this is 7 over 2A equals to AD. So AD is equals to 7 over 2A. So this part here, 7 over 2a. Okay, what's another thing that we can find? Okay, you look, we want to find another expression for OE. Okay, let's be clear what are we trying to find. We want another expression for OE. So according to the graph here, can we say we can find OD plus DE? Okay, do we have DC or can we find DC? Okay, can. With what we have just now, you look back into the first question. First question, we found what is OC. So can we find what is DO plus OC? Okay, we want another expression for OE right now. So let's find what is DC. DC is DO plus OC. DO, look at the diagram. Okay, we got 7 over 2 and A. So can we say it's minus 7 over 2A minus A? Okay, this is DO. Then plus OC. Let me see, where's OC? Minus 2A plus 3B. Okay, you look back into the first question, minus 2A plus 3B. Okay, let's calculate for this side. Okay, this will give us minus 9 over 2A minus 2A plus 3B, and we end up with minus 13 over 2A plus 3B. Okay, from here, right now, we construct an expression for OE. Okay, can I say this whole thing is DC, right? Which is what we just found here. Minus 13 over 2A plus 3B. Can I say DE is part of this? So can we put a mu over here? Okay. We put another unknown to represent the ratio of this. Okay. So we're going to say that DE, this is DC. Can we say that DE is mu of DC because it's a magnitude or a scalar vector of scalar quantity of DC, or we can factorize out a value. Okay, so now this is how I will write it. OE is equals to OD plus DE. Okay, look at the diagram. OD plus DE because I want to find another expression for OE. Okay, where is OD? OD, A plus 7 over 2. A plus mu DC. 9 over 2, A plus mu DC, negative 13 over 2A plus 3B. Okay, we gather all the A together. 9 over 2 minus 13 over 2 mu A plus 3 mu B. Now we've got two expressions of OE. We're going to equate both OE to each other. 9 over 2 minus 13 over 2 mu A plus 3 mu B. Okay, what's given to us? Lambda B. So we can say is 0A plus lambda B. Okay, we're going to equate the A with the A. A is 9 over 2 minus 13 over 2 mu equals to 0. 9 over 2 equals to 13 over 2 mu. Okay, both the two cut off with each other, then we'll get mu equals to 9 over 13. B, 3 mu is equals to lambda. 3 times 9 over 13 equals to lambda. Lambda is 27 over 13. All right. Okay, so draw out the diagram so that it's clearer for you all to see. Got it? Okay, if you can do this, can you just type 10? Much clearer, right? Okay, the explanation here. All right, good job, good job. Okay, let's move on to the next question. All right, question 11. Just now, a lot of you also asked this one. How do we do this? A particle P moves in a straight line and passes through a fixed point. At time t seconds, its displacement from O, s meters, is given by these two. Okay, so we got two different type of movement here. Okay, the first 3 seconds is t plus 6t squared minus t cubed. Then from third second to k second is 12t minus 1 over 3t squared minus 3. Okay, it is given that for 3 to k, the velocity of p is positive and its acceleration is negative, the maximum velocity of P occurs when t equals to 2. Okay, so this is the max V value. At the axis below, sketch a VT graph for the first k seconds of the motion of P. 4-mark question. What do we need to find first? Okay, we've got expression of S. First thing is that we need to convert the S to V first because we are drawing a V graph, right? But we don't know what's the V equation. So this is your first 3 seconds. So you got 2 equations here. Okay, let's do the first part first. From 0 to 3 seconds, we are going to differentiate the S, okay, because V is ds over dt. Okay, let's put here V1, okay. V1 will be equals to, okay, I will rearrange this one. I'll do from the back first. Never mind, later I rearrange. 1 plus 12t minus 3t squared. Okay, this is a what? Quadratic equation, right? Okay, what do we need to check? So we use the same acronym, SIM. We need to know what's the shape, any intercept that we need to put, then the maximum point or minimum point. Okay, let's start with S. What's the S here? S, this is a set phase graph. Okay, do we need to find the intercept? Okay, we can try to find. Let me see. Minus 3t squared plus 12t plus 1. Okay, you can find your x-intercept and y-intercept. You see whether it's within the domain of 0 to 3 or not first. Okay, because we don't know how the graph looks like or where is it, right? Okay, so let's find the intercept. Okay, x-intercept, y is equals to 0. So you got 3t squared minus 3t squared plus 12t plus 1 equals to 0. Okay, this one can factorize now. 3t squared minus 12t minus 1 equals to 0. Okay, can we solve for this one? Okay, I think the value not so nice. Okay, so this one I will put it aside first. Okay, later only count because normally normally for this one, because we already know that it's probably, okay, it will either be probably something like this or like this. Okay, we don't know. So what I'll do is let's check for this domain here first, 0 and 3. Okay, 0 and 3. And then they also say the maximum point, okay, or the turning point is when maximum velocity is when t equals to 2. So I check for y-intercept first. Okay, y-intercept is when t equals to 0 lah. Okay, so I will check for the domain. Okay, okay, this one later. Okay, later. So I will do this one. T is equals to 0. Okay, this is the y-intercept. What's the v value? V equals to 1. Okay, I'm substituting into here. Then t equals to 3. V is equals to negative 3 times 3 squared plus 12 times 3 plus 1. Okay, this is minus 27 plus 37. We get 10. Okay, so we will get here 310. 310, 0, 1. Okay, then find the max point. They say it is at t equals to 2. V is equals to negative 3 times 2 squared plus 12 times 2 plus 1. Okay, negative 3 times 4 plus 24 plus 1 minus 12 plus 25. So this is 13. 2, 13. Okay, so I think with this information here, none of it will be a floating upside set phase graph. Okay, so you see 0, 1, maximum point is 213, then the most right point is 310. Okay, so this is what I will label here. Okay, here you got 1, 2, 4, 5, 6, 7, 8, 9, 10. Okay, around here. 10. Then let's put here 13. Okay, we got here then 1, 2, 3. Okay, let's put here 1, 2, 3. Okay, got 2 and 3. Okay, so first point 0, 1. Second point 2, 13. Third point 3, 10. Okay, so the first part of the graph looks something like this. Okay, it's a quadratic graph until here. Okay, from 0 to 3. Now, the second part of the graph, s equals to 12t minus 1 over 3t squared minus 3. Okay, we are going to differentiate that part. So here will become 12 minus 2 over 3t. Okay, 12 minus 2 over 3t. This is a straight line graph because it's a y equals mx plus c. Right? The shape, straight line. Yeah. What kind of straight line? The gradient is negative, so it is going down. Okay, so we know that it will start from here. Okay, what we can do, we can just double check. We substitute in the 3 into the equation also. So at t equals to 3, okay, we check here, v is equals to 12 minus 2 over 3 times 3. Okay, this is also equals to 10. So it's correct already, the point. Okay, where is k? We don't know. Okay, we don't know where is the k value. So if your t equals to k, all we know is the graph is going down because of the negative gradient. So this second part of the graph, what I'll do is I'll just draw a straight line down like that. Okay, until here. I don't know. Okay, I don't know where is it. But what I do know is that it won't go to the bottom of the graph. Why? Because of this sentence. The velocity of p is positive. So it still needs to be above the graph. Got it? Okay, it can be anywhere above. Okay, that means if it's here, okay, we don't know what's the slope also. This one we just roughly estimate only. As long as we show it's going down. Okay, so this part here, we can label here. V is equals to 12 minus 2 over 3 t. Then this part here, V1 is the 1 plus 12t minus 3t squared. Very unique question. Okay, good. Yes, I think most of you got asked this question. All right, let's look at question B. We'll look at question B. The total distance traveled by P for 0 to K is 57 meters. Given that when T equals to 3, the distance and displacement of P from O are equal. Find the value of K. Okay, what do we do for this one? We got two different distances, right? Okay, so what do we do? Okay, let's write down the equation first. We got S1 and S2. So I'll write here S1 equals to T plus 6t squared minus t cubed. The second one, 12 t minus 1 over 3 t squared minus 3. Okay, this is from 0 to 3. This is from 3 to k. Okay, they want us to, they say when t equals to 3, okay, let's substitute t equals to 3. Okay, so at t equals to 3, I will substitute into the first equation. 3 plus 6 times 3 squared minus 3 cubed. This will be 3 plus 6 times 9 minus 27. 3 plus 54 minus 27, which will be equals to 30. Okay. So the entire distance is 57 meters. So the remainder distance, okay, remainder or remaining distance, this is from 3 to k, will be equals to 57 minus 30, which is 27. Okay, 27. All right, now let's look back into the graph. Okay, let me see if I can bring it down here. Copy, paste. All right. Okay, like that easier to see. Hey, if we look at the graph right now, what do we know about the VT graph? VT graph is area under the graph, we will get the distance. Okay, that means from here to here. Okay, here I didn't draw that accurate. So this one should be the 3, should be here. Okay, this is 27 meters. How to calculate this one? Can do or not? Can, right? Okay, so this one we can use area of trapezium. Okay, let's see what is the values that we have. So we've got this part here, which is 10. Okay, this one when our t is equals to k, so this part here will be 12 minus 2 over 3k. Okay, so this section here plus this section here. And then this part here is k minus 3. Okay, you all can draw it out. So area of the trapezium, we use half a plus b times height. So it will become half times 10 plus 12 minus 2 over 3k times k minus 3 equals to 27. Okay, let's simplify this one. We multiply the whole thing by 2. So this one, the 2 will go to the right-hand side. Here will be 22 minus 20 minus 2 over 3k, k minus 3 equals to 54. Open up the bracket. Here will be 22k minus 66 minus 2 over 3k square plus 2k equals to 54. Okay, from here, let's see, how can we simplify it? Okay, I will shift everything to the right-hand side. Or we remain like that first. Minus 2 over 3k square. Okay, 22k plus 2k will be 24k. It is right. Minus 66. Okay, it looks like something is wrong here. 22k minus 66 minus 2 over 3 square plus 2k equals to 54. Okay, correct. Okay, minus 66 minus 54. So 66 and 54, here will be 0. Then 120. Okay, minus 120 equals to 0. Wow, the value, not nice, this one. Okay, I will multiply the whole thing by 3. Okay, by minus 3. Multiply by negative 3. Okay, this one will become 2k square. 24 times 3. 72 minus 72k. Okay, 120 times 3. This one will be plus 360 equals to 0. Then we divide the whole thing by 2. This will become k square minus 36k plus 180 equals to 0. Okay, how can we find the factor of 180? It's either you factorize it or you put into quadratic formula. Okay, this one actually can get a nice value. So we will get k minus 6, k minus 30 equals to 0. K is equals to 6, and then k is equals to 30. Okay, we will use k equals to 6. Okay, we'll use k equals to 6 because this is the first type. So we reject this one. Now, do we need to find any other things? Yeah, so I think this is it. K equals to 6 or k equals to 30. Okay, actually we can check this. We need to check this one. We substitute the k into the equation. So 12, so we substitute, so sub k. Okay, sorry, we actually have to test this one. Sub k into v2. So v 12 minus 2 over 3 times 6. 12 minus 2 times 2. This one will be 12 minus 4, positive 8. v2, 12 minus 2 over 3 times 30. 12 minus 2 times 10. This one you get negative 8. Okay, the thing is, we need to check for v to be positive. That's why we reject. Okay, reject this as v is positive. We don't want a negative v value. All right. Okay, tough question. So a bit confused. I think this question 10 and 11 are a little bit tough. Okay, let's do one more. If you all can do this, can you all type 11? Okay, faster finish up the last one already. Okay, let's go to the last question. Okay, last one I think much easier. Right. Okay, the final question, number 12. The normal to the curve y equals to 4 over x squared plus ax plus 7 at the point where x equals to 2 has equation x plus 4y equals to b. Find the value of a and b. So what we got to do, we got to find what is the equation of the normal to the curve at x equals to 2. Okay, equation of normal. We need m, we need x and y. Okay, so we need the gradient of the normal, which is dy over dx. Then we need the equation of the then the x and y, then we put into the equation. Y minus y1 equals to mx minus x1. Okay, so let's find dy over dx first. Y equals to, we rewrite it into 4x to the power of negative 2 plus ax plus 7. dy over dx is equals to negative 8 x to the power of negative 3 plus 8. Okay, we're going to substitute x equals to 2. Okay, what is the gradient? So this is the gradient of the tangent. Okay, we change it back also. Negative 8 over 2 cubed plus 8. Okay, this one will be negative 8 over 8 plus a. We get negative 1 plus a. Okay, I will write it as a minus 1 so that when we write the gradient of the normal, we will get the negative reciprocal. So negative 1 over a minus 1. Okay, this one, negative reciprocal. Okay, we also need to find the y value. So we're going to substitute x equals to 2 into the y equation. Back to the question, 4 over 2 squared plus a times 2 plus 7. 4 over 4 plus 2a plus 7. Okay, this one we will get 2a plus 8. All right, so we have x equals to 2, y equals to 2a plus 8. Then the gradient of the normal, okay, we just write as gradient, negative 1 over a minus 1. We're going to substitute into y minus y1 equals to mx minus x1. Okay, this one is equation of normal. We should get y minus 2a plus 8 equals to negative 1 over a minus 1 bracket x minus 2. Okay, let me open up this bracket first. A minus 1 bracket x minus 2. Okay, I'm gonna multiply the a minus 1 up. So this will become a minus 1 bracket y minus 2a minus 8 equals to negative bracket x minus 2. Okay, open up the bracket. We will get ay minus 2a squared minus 8a minus y plus 2a plus 8 equals to negative x plus 2. Okay, we rearrange it into x plus 4y equals to b. So I'm going to put the x and the y all to the left-hand side. Okay, let's see. We got ay, we've got negative y, then we've got x here. Okay, let's shift it all to the left-hand side. So this will become x plus ay minus y equals to 2 plus 2a squared plus 8a minus 2a minus 8. Okay, I'll write it into the form a plus 8 minus 1y. Okay, rearrange this. This will be 2a squared plus 6a minus 6. Okay, so I got this form already. Now I want to compare it with x plus 4y equals to b. Okay, this is what is given in the question. Okay, let's compare this one. Okay, so for the y, okay, the y, we got a minus 1 equals to 4. A will be equals to 5. Okay, for the b value, can we say b is 2 times 5 squared plus 6 times 5 minus 6. 2 times 25 plus 30 minus 6. 50 plus 24. Therefore, b is equals to 74. This is the final answer. All right. Okay, so this is it. This is the May-June 2025 paper 1-3. This is the last paper of the non-calculator May-June series. All right. Okay, if you can do this, can you just type a 12? Okay, congratulations, everyone. We've got one more paper to go. I'll see y'all in the next class. Cheers.